Dear students, we will see a mechanical translation system problem. So to find the transfer function of mechanical translation system, we have to determine the transfer function of mechanical translation system. This is your aim. So this is a different translation system given. We have two masses and two springs and one dashpot, and then this is also B1, B2 also a dashpot, which is connected to the mass M1 and M2. Okay. So in your B and K, this is connected in between two masses. This is connected only to mass 1, and B1 also connected to mass 1, and B2 is connected to mass 2. Okay. So we will start with, first we must draw a free body diagram. For mass 1, you should draw a free body diagram. What are the elements which is connected with mass 1? So we can see here, with mass 1, your K1, B, K and your B1, all the components are connected. So Fm1, the mass, the force, opposing forces by the masses Fm1 and B1, Fb1, and the same way Fb and Fk1 and Fk. Okay, these are the opposing forces which is developed by the components which is connected to the mass 1. So first we have to write the opposing force balance equation. This is M1, Fb1, Fk1 and Fb and Fk. You can see here, since Fk and Fb, both this B and K is connected in between, so this is going to suffer with two displacements, x1 minus x. Other three are connected only to mass 1, so it is suffering only one displacement. Okay, so according to Newton's second law, force balance equation, there is no force applied, so all the opposing force equal to 0. So sum of all the opposing forces equal to 0. So just if you add all this and equal to 0, add all this and equal to 0. And then you must apply the Laplace transform equation. Laplace transform for d square x1 by dt square is nothing but s square into x1 of s. Same way dx1 by dt is x into x1 of s for x1 and all x1 of s, x and x of s. So just if you substitute here, you will be getting this type of equation, and then simplify this equation so that you should take x1 of s common and x of s common. So you will be getting this equation. Okay. So after getting this equation, so your x1 of s is equal to, if you substitute, if you cross multiply like this, x1 of s equal to this term will count down, so it becomes like this. Okay. For next M2 mass, you should draw your next free body diagram. Okay. So draw your free body diagram for mass M2, and these are the force acting. Here you can see a force, applied forces there, F of t, and these are the opposing forces, Fm2, Fb2 and Fb and Fk. Okay. So simply as the same way previously, we have to write a force balance equation for this also. So for M2, it is M2 d square x by dt square. For B also B2 dx by dt, and your B and K is connected common, so you should suffer two displacement, x minus x1, x minus x1 for K also. Okay. And then according to Newton's second law, force applied equal to opposing force. Here force applied is F of t is there. So F of t is equal to all these forces. Add all the forces and equal to F of t. Okay. And substitute all the force balance equations. Okay. And you will be getting this type of equation. Again, you apply a Laplace transform with 0 initial conditions. Okay, Laplace transform if you apply, you will be getting this type of equation, d square x by dt square will become x square into x of s, and same way b2 dx by dt becomes b2 into s into x of s. The same way your d by dt will become s into x of s, and your x alone x of s. D square means s square into x of s. This is your Laplace transform. Okay, simply with the help of this, you can convert this equation to Laplace transform equation, and separate all this x of s and x1 of s separately, and make your x1 of s, you can equate and find out. Okay, here you can, already we found the x of s. X1 of s is x of s into bs plus k divided by this one. So whatever the differential, you need a transfer function of your output by input. Okay, input is force applied f of s, output is your x of s. So x of s by f of s you need to find out. So accordingly we need to substitute. Okay, we need to substitute this x1 of s in this equation. In this equation you should substitute the x1 of s. Okay, in the x1 of s place I substituted here this equation. So now you can see only the x of s terms will be there. Okay, so take your x of s common and you will be getting this type of equation. So x of s by f of s gives you, this is your transfer function. That's all. This is about the problem. So always for the given problem, you must see how many masses are given. Okay, so for that you should draw the free body diagram and you have to proceed writing the force balance equations. and then you have to simplify whatever the transfer function they are asking. Accordingly, you have to simplify and you should find out the answer. That's all. Thank you.